We have ignition and we have liftoff. The initial calculation showed that we were going to be in great danger of getting really fuzzy pictures if we didn't do something to the spacecraft. It's that humility that science gives us. In the vastness of space exists a silent traveler, a relic of human exploration. NASA's Voyager 1. It has been venturing through space for over an amazing 45 years, still sending us valuable information from the distant parts of our solar system. But now something strange is happening. Voyager 1, now 24 billion kilometers from Earth, has begun sending mysterious data that has puzzled scientists. In this video, we will embark on a journey of discovery to unravel the mystery behind what's seriously wrong with the Voyager 1 probe. Could we lose contact with Voyager 1, signaling its potential end? Could aliens eventually take over Voyager 1? Join us as we venture into space to investigate these strange signals and understand what's really happening to this remarkable spacecraft. To understand the gravity of Voyager 1's situation, we must first appreciate its incredible journey. The Voyager mission, launched in the summer of 1977, was expected to last 5 years. Yet, to everyone's astonishment, Voyager 1 and its companion, Voyager 2, have defied these predictions, surpassing their expected lifespans. But not just that. For over 45 years, they've been continuously beaming back invaluable scientific insights from the farthest reaches of our solar neighborhood. Initially, these twin spacecraft were dispatched with a mission to explore Jupiter and Saturn, a task they fulfilled with great success. However, Voyager 2 didn't stop there. It embarked on a remarkable journey, making the very first up-close observations of Uranus in 1986 and Neptune in 1989 as part of what was aptly named the Voyager Grand Tour. Yet their most remarkable feats were still ahead. In August 2012, Voyager 1 achieved an unprecedented milestone when it ventured into interstellar space just 35 years into its mission. The world, however, only learned of this momentous event in 2013, when scientists meticulously reviewed the data sent back by Voyager 1. In 2013, NASA officially declared that Voyager 1 had ventured beyond the Sun's influence into interstellar space, where it encountered a continuous stream of particles and magnetic fields unlike anything it had previously experienced. Voyager 2 joined its sibling in this cosmic frontier in 2018, a remarkable 17.07%. These Voyager missions are unparalleled in their contributions. They've offered us exclusive insights into our solar system and its surroundings. The probes have been busy studying how the interstellar medium interacts with the solar wind. A stream of charged particles perpetually emitted by the Sun. Voyager data has also shed light on the heliosphere, a bubble of charged particles enveloping our solar system, sculpted and influenced by the interstellar environment. According to NASA, scientists have combined Voyager observations with data from newer missions to get a more complete picture of our Sun and how the heliosphere interacts with interstellar space. Ultimately, Voyager 1's enduring mission has broadened our horizons and ignited our collective imagination, etching a timeless legacy in the annals of space exploration. Meanwhile, scientists estimate that our first contact with extraterrestrials could be in 2029. They believe that if there were extraterrestrials, the messages sent to them using Voyager 1 would have reached them as early as 2002. While this will be a paradigm shift in the history of humanity, many people are eager to know what could happen if Voyager 1 meets extraterrestrial life. We'll get into this in a bit, but first, how has Voyager 1 persisted for an astonishing 46 years and counting? When we talk about Voyager 1's incredible endurance, its toughness stands out. Imagine a machine navigating through the harshest place you can think of: space. In space, you've got wild radiation, extreme temperatures that can freeze or fry, and even tiny space rocks zipping around. Most things wouldn't stand a chance out there, yet Voyager 1 has been trucking along for a remarkable 46 years and 5 days, counting from September 12, 2023. A big reason behind the staying power is that it was built well. A salute to the brilliant engineers and officials who crafted the spacecraft. They ensured it could handle a pounding from cosmic radiation, extreme hot and cold swings, and those pesky little space rocks. The probe has also survived for so long due to its power source. You know, solar panels, right? Those flat things on some rooftops that soak up sunlight to make electricity? Well, Voyager 1 couldn't rely on those because it ventured far from the cozy embrace of the sun. Instead, it uses something more exotic: nuclear batteries, also known as radioisotope thermoelectric generators, RTGs. These aren't your typical batteries. They convert heat from the natural decay of plutonium into electricity. These RTGs have been Voyager 1's power systems, a reliable heart keeping it strong for more than 4 decades. Over time, their power output has dipped due to radioactive decay, but they still provide enough juice to keep all the scientific instruments on board humming. Now, Voyager 1 isn't just an original spacecraft. It's also a brainy explorer. It's packed with instruments like a scientific Swiss Army knife. Voyager 1 is equipped with a cosmic ray subsystem, CRS, high-gain antenna, imaging science subsystem, ISS, infrared interferometer spectrometer and radiometer, IRIS, low-energy charged particles, LECP, magnetometer, MAG, optical calibration target, photopolarimeter subsystem, PPS, planetary radio astronomy, P, plasma science, PLS, plasma wave subsystem, PWS, radioisotope thermoelectric generators, RTGs, and ultraviolet spectrometer, UVS. These instruments aren't just fancy decorations. They've done some serious work. Voyager 1 has used them to unravel mysteries about giant planets and their moons. Close-up snaps from the spacecraft have given us the lowdown on Jupiter's swirling cloud patterns, wild winds, and storms. It even spotted volcanoes on Jupiter's moon Io. Over at Saturn, the rings were more than just pretty jewelry. They had peculiar twists, turns, and spokes, and they come with a whole lot of ringlets. But it's not just about pretty pictures. These instruments have also been cosmic detectives, studying cosmic rays, probing charged particles, poking at magnetic fields, and eavesdropping on plasma waves. Meanwhile, as Voyager 1 hurtles through the cosmic void, it carries a remarkable treasure, a message from Earth destined for the unknown. This unique record, known as the Golden Record, is humanity's attempt to communicate with any extraterrestrial being that it might encounter on its endless journey. The Golden Record is a remarkable artifact, a 12-inch gold-plated copper disc holding a trove of sounds and images carefully chosen to depict Earth's diversity of life and culture. It is a window into our world, a story of our species and planet, an attempt to bridge the gap between civilizations separated by the vast expanse of space. Within the confines of this small, shimmering disc are 116 images and a symphony of sounds. Among them are the harmonious melodies of our music, spoken greetings in 55 languages from different corners of our globe, and the raw, unfiltered sounds of nature, thunderclaps, the songs of birds, and the haunting calls of whales. Each element was handpicked by a committee led by the renowned astrophysicist Carl Sagan, representing a tapestry of our world's cultures and experiences. The Golden Record is entrusted to Voyager 1 and its twin craft, Voyager 2. It's fascinating to think that these Voyagers carry a message from Earth that could be discovered by extraterrestrial life in the distant future. If by some incredible chance an advanced extraterrestrial civilization were to come across Voyager 1 and retrieve the Golden Record, it would be a momentous event in the history of interstellar communication. Here are 3 possibilities of what might happen. The extraterrestrial civilization would likely attempt to decipher the contents of the Golden Record. With their advanced technology, they could understand the visual and auditory information encoded on the disk. Secondly, if extraterrestrial beings were capable of interstellar travel or communication, scientists predict that they might subsequently return a signal expected to reach Earth by 2029. Alternatively, they might choose not to interfere with Voyager 1 and simply study it as a historical artifact. They might want to respect the principle of non-interference in other civilizations' development, a concept explored in many science fiction stories. In any case, if there were ever an encounter with extraterrestrial beings, it would be a massive and potentially world-changing event for humanity. However, Voyager 1, despite its long and faithful service, has recently introduced an element of intrigue into its mission. It has begun transmitting perplexing data from the fringes of interstellar space, sending NASA engineers into a state of bewilderment. This anomaly emanates from a crucial onboard system known as the Attitude Articulation and Control System, ACS. This system is responsible for measuring, reporting, and adjusting the spacecraft's position in the unforgiving expanse of space, ensuring that its antenna stays pointed toward Earth for communication and data transmission. Yet, inexplicably, the ACS returns data that contradicts the spacecraft's actual movements and orientation. It's as if Voyager 1 has become disoriented, uncertain of its location in the cosmic void. NASA's assessment of the situation is reassuring yet perplexing. According to NASA, despite the erroneous data from the ACS, Voyager 1 continues to function and gather scientific data as expected. This suggests that the ACS may not be the sole source of the problem. Other onboard systems might also be contributing to this puzzling behavior. Even more baffling is that Voyager 1's signal hasn't weakened, implying that the high-gain antenna remains steadfastly pointed toward Earth, a testament to the spacecraft's resilience and adaptability. Speculation has arisen about the cause of this anomaly, with the consensus leaning toward a software glitch or a malfunctioning onboard system. Given Voyager 1's extended duration in space, such technical hiccups are not entirely unexpected. However, the spacecraft's extraordinary distance from Earth poses a significant challenge for NASA engineers. Voyager 1 operates on commands that take nearly 22 hours to reach it, creating a substantial delay in communication and response time. Moreover, the faintness of its signal necessitates careful coordination between NASA's Deep Space Network and Voyager 1's onboard systems. Despite these hurdles, NASA's engineers are resolute in their efforts to diagnose and rectify the issue, ensuring that Voyager 1 can continue its remarkable journey through the cosmos. As we ponder the fate of Voyager 1 and its enigmatic data transmissions, it is a poignant reminder of the incredible endurance and achievements of this pioneering spacecraft. Its mission, now spanning over 4 decades, has gifted humanity with unparalleled insights into our solar system and beyond as Voyager 1 continues its journey through interstellar space. It serves as a beacon of human ingenuity and ambition. Launched in an era when computers were far less advanced than today, the spacecraft has demonstrated extraordinary resilience, effectively outlasting its initial mission parameters. Engineers at NASA are not only concerned about its current functionality, but are also fascinated by the possibility of what it may uncover in the future. The vastness of interstellar space poses unique challenges for Voyager 1, such as the interaction with cosmic rays and other high-energy particles that could affect its onboard instruments. The spacecraft's ability to withstand such harsh conditions is a testament to the foresight of the mission designers, who implemented robust shielding to protect sensitive components. Furthermore, Voyager 1 is traveling through a relatively unexplored region of space, making every transmission a potential goldmine of new data. One of the significant challenges facing Voyager 1 is its diminishing power supply. The RTGs, while reliable, produce less electricity over time due to the natural decay of plutonium. As power levels decline, engineers are faced with the critical task of managing resources. This includes prioritizing which scientific instruments to keep operational. The mission team must make careful decisions, often sacrificing one experiment for another to maximize the return on investment in scientific knowledge. Interestingly, the data sent back by Voyager 1 continues to yield surprising discoveries about the interstellar medium. Scientists are especially intrigued by its ability to measure solar wind characteristics and the magnetic environment beyond the heliosphere. This information enhances our understanding of how our solar system interacts with the greater cosmic environment and may provide insights into the nature of other star systems. Moreover, Voyager 1's journey has inspired a new generation of scientists and engineers. The success of this mission has become a touchstone for discussions about future exploration missions beyond our solar system. Concepts such as interstellar probes and advanced propulsion technologies are gaining traction, fueled by the desire to build upon the legacy of Voyager. In addition to its scientific contributions, Voyager 1 also acts as a symbol of hope and curiosity. Its golden record is not just a message. It encapsulates humanity's aspirations and dreams. The inclusion of diverse cultures, languages, and music on the record represents a collective yearning for connection, transcending the boundaries of Earth. If an advanced civilization were to encounter Voyager 1, the implications would be profound, raising questions about our place in the universe and the potential for communication across light years. As we look to the future, the ongoing journey of Voyager 1 encourages us to consider the limits of our knowledge and the possibilities that lie beyond. The exploration of interstellar space is not just a scientific endeavor. It is a reflection of humanity's intrinsic desire to seek out the unknown, pushing the boundaries of what we understand about existence itself. Each signal received from this iconic spacecraft serves as a reminder of our quest for knowledge, a journey that began with a simple launch but has evolved into a monumental narrative of exploration and discovery.